So here we're going to be looking at Nash equilibria in a payoff matrix, and this is from my textbook in microeconomics, and I'm Rickard Friberg. Okay, so in a previous video, we looked at the following game, where I have erased some information. So we had a case where the row player had a payoff of 5, and the column player, orange, had a payoff of 5 as well in the case where both cooperated. In a previous video, we looked at the best responses under this setup. So we walked through the table, first putting ourselves in the shoes of black, say, should black cooperate or play aggressively? Well, it compares the best responses to different strategies for orange. And we said before that I've essentially walking through for black, then putting ourselves in the shoes of orange, comparing then cooperate to play aggressively. Play aggressively is given a best response as well here. Okay. So we can see, what do we want to do with this? Well, we want to predict how firms are going to be playing. And we can see that in this case, we had call it dominant strategy for each of the players to play aggressively. No matter if orange was cooperating or playing aggressively, the payoff for black was greater if it played aggressively. Similarly for orange, its payoff of playing aggressively compared to 8 and 1 compared to 2 was greater, irrespective of what the other player did. Okay, so each had a call it dominant strategy of playing aggressively. So, some games have that property. Other games do not. A useful tool then is what we call a Nash equilibrium. Okay, so in these normal form games, in the payoff matrix here, for thinking just first mechanically or mechanistically, a Nash equilibrium is where two of the strategies, where both strategies are underlined. Okay. Mechanically, they're best responses to each other. Another way of saying that is that in this Nash equilibrium, there's no deviation that would be, no unilateral deviation that would be profitable for any of the players. Okay, so this is an example of what we sometimes call a prisoner's dilemma kind of game, where the predicted payoffs, if each is playing best response to the others, is that they get a payoff of 2. They would both be better off if they could get a payoff of 5 each and cooperate. But the problem here is, how should they coordinate on that if they don't trust each other, if they can't write binding agreements? So there's no, they wouldn't want to unilaterally deviate. If orange is playing aggressively, black will not do better by cooperating as well. It would instead be decreasing its payoff, or vice versa. For orange, there's no incentive to deviate from playing aggressively if it is the only one doing so. So unilateral deviations are not profitable in this Nash equilibrium. But if they together could, both deviate and play another, that could be possible. Okay, so here we have a unique Nash equilibrium. There's only one such cell where they cannot profitably deviate. But we could look at another type of payoffs. So say 10-10 in this case instead. So this is by just changing the payoffs, we change the game. And now this is what we instead call a coordination game, and we'll see shortly why. So again, walk through looking at best responses. So we're saying, putting ourselves first now in the shoes of black, choosing cooperate or play aggressively. If orange cooperates, black then compares payoff of 10 to 8, 10 is greater than 8, so black would choose to cooperate. If orange plays aggressively, black would compare the payoffs 1 to 2. 2 is greater, so if orange would play aggressively, the best response for black would be also to be aggressive. And vice versa. We can then move over to orange, comparing 10 to 8. 10 is greater, or 1 to 2. 2 is greater. Okay, so we now have two cells where both strategies are underlined. We have two sets of strategies that are Nash equilibria. These are sets of strategies such that none of the players has an incentive to unilaterally deviate. Okay, so they would both prefer this outcome to that, but if for some reason black believes that orange might play aggressively, black does not have an incentive to unilaterally deviate. It's only if both deviate and change their strategy that they can do better.